Hello, this is Mr. Bradsby. We're going to do another math lesson. Here we go. This is a rectangle here with squares. You see that picture? Right here. And I would like you to determine how many of these little squares are in this rectangle, or special rectangle, a square. So put me on pause. See if you can figure out how many squares, little squares here, are in this rectangle. Okay? Put me on pause. All right, well, I don't know how you did it, but let's see. Here's how I would do it. I would look at how many there are across here. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 all the way across. Okay, this is like the area rectangle, except it's already divided into the squares, and you could count them all if you want, but then I would count down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 across and 10 down. So we could multiply the 10 times 10. Or we could count by tens even. We could go, there's 10, there's 20, counting down. There's 30, third one down, 30, 40, 50, 60, 70, 80, 90, 100. So how many are there? There's 100. This is a hundreds grid, I call it. It's 10 by 10, which is 100. And we talked about that. We talked about that 10 multiplied by 10 is 100. And it follows that rule we talked about. 10 times anything is that with a 0 behind it, the number with another 0. Like 10 multiplied by 4 is 4 with a 0, 40, and that's 4 tens. Makes sense, doesn't it? So anyhow, I wanted to picture what 100 looks like, because that's a lot, isn't it? That's a lot. Well, it would be like we're talking about money. It would be 100 pennies would make $1, and so that's what that would be. But here is a 100 grid. That's what I call it. It's got 100 squares in it, and that's what 100 pictured. Like it's a square in this case, not a rectangle, but a square is a special rectangle because it fits all the definition of a rectangle. So here it is, 100 grid. Isn't that a lot? Well, this brings up the idea of place value, which we've already talked about. We have the ones, the tens, and the hundreds. And this is what the hundreds is. How many of these big grids here do we have? Hundreds of them. So suppose we have something like 475. That's the way it's read. Well, if we look at the place value down here, that would be 5 ones, 7 tens, 4 100s, 475. 475. Wow, so it'd be 4 100s, 7 of these tens. There's a 10. So it'd be 7 of those. 3, 4, 5, 6. We got down here, so it'd be 7 of those. 4 of the big grids. 7 of these tens. That'd be the picture here with the green. 7 of the tens, and just 5 ones. 1, 2, 3, 4, 5. So that's what it would look like. 4 of these. Isn't that something? That's a lot of squares. Okay. Then the ones, we know that's just the 1. The tens, is 10 times 1, 10 times larger. So that's what going from the ones to the tens, it's 10 times larger. And we know that you multiply the 10 by 10, the hundreds is 10 times larger than the tens. So everything goes up by 10 times as much. Ones, tens, hundreds. And the way that it's read, 475, here's another number. It's read 382. 382. There's no ands or anything in there, 382. So it'd be 3 of these hundreds, 8 of the tens, and just 2 little ones. 382. Okay, well now suppose we had a problem, like in multiplication again. 400 times 3. Well, I'm picturing that with very small squares, but these are 100 grids, okay? This represents a 10 by 10 or 100. So we have 1, 2, 3, 400 across, and we have 1, 2, 3 of these down. 3 400s. And that's what this is, isn't it? 400 multiplied 3 times. So we got the 1, 2, 3 of these 400s. Well, then what is the answer? What's the answer to 400 multiplied by 3? Well, here's the picture here, so we can count them. 1, 2, 3, 400, 3 times. So 500, 600, 700, 800, 900, 1000, 1100s, 1200s, 12 100s. Okay? Well, we know that when we multiplied by 10, say 20, well, no, let's make it the 440 multiplied by 3, right? We knew that was 3 times 4 is 12, and it's got to have a 0. Okay, 3 times 4 is 12. Well, 3 times 400 then would have to be 12. 3 times 4 is 12 hundreds. And that's what we modeled over here. It is 1200. 3 400ths. So when we multiplied by 10, say 10 multiplied by 2, we knew that was 20. You add a 0 to the 2 times the 1. Okay? 40, you add a 0 to the 12. Well, now we have 400 multiplied by 3. 3 times 4 is 12, but it's hundreds, isn't it? It's 2 zeros. So we have to put 1200. 3 times 400, 1200. And there's the picture, and there's the work we do. So now when we multiply by hundreds, we got to have 2 zeros. We multiply by tens, we got to have 1 0. Just like here, 1 0 in tens. 2 zeros in hundreds when you multiply by 100. So I've got 3 problems down here that we need to work. We did an example up here. 400 times 3 is 1200. Well, I'd like you to put me on pause, work these 3 problems down here. 1, 2, 3. They're pretty easy. 200 times 7, 500 times 8, 600 times 3. Work those problems. After you're finished, come back and we'll talk about them. So work these problems. Put me on pause. Well, I'm sure those were pretty quick for you. Just what we were talking about. We're multiplying by hundreds. So 7 times 200. 7 times 2 is 14, and it's hundreds, 1400. A lot of times you'll see a comma put in there which says 1,400. Either way, 1,400. And you don't have to have the comma there, same thing. But it's 14 with hundreds, 2 zeros. 8 times 500. 8 times 5 is 40. And again, it's hundreds. So if you want to put the comma in, that would be 4,000. 3 times 600. Well, sometimes people say, well, it's 3 times 0, 0, 3 times 0, 0. That's true, no zeros. 3 times 6 is 18. 1800 or 1,800. So that's how you multiply, right? You multiply by hundreds. Pretty easy, isn't it? Okay, well, let's look at a problem with hundreds in it. 245 multiplied by 6. Well, the first method we tried to use before, or the first thing, was the rectangle, the area of the rectangle. So if we wanted to do the area of the rectangle model, we have to add something now. We have to have a hundreds, then a tens, and then a ones, okay? So 245, expanded notation, that's 200 here, it's 40 here, and 5 there. 245 multiplied by 6. So the area of the first rectangle here, this one, would be 6 times 200. And what we just said, that is 1,200. And we'll write it down like we do with the area of the rectangle, 1,200. 6 times 40 is the next rectangle over here. 6 times 40. Okay? 6 times 4 is 24, and it's tens, so 240. Okay? The next one then is 6 times 5, which is 30. So we have 30 more to add on. So there it is. 0 when you add it. 4 and 3 is 7. 2 and 2 is 4. And 1 more. So we get 1,470. Well, this goes right into the expanded notation model. If we want to work this problem, 245 times 6, we expand it, but it's hundreds. 200 plus 40 plus 5 multiplied by 6. We'll write them down here. 30, 6 times 5. 6 times 40, 240. 6 times 200, 1,200. Add them up. 0, 7, 4, 1470. So, of course, you get the same answer. But that's using expanded notation. Another one we did, which was a short version of this, was 245 by 6, and we just wrote down the partial sums. Instead of expanding it out, we're just going to try to do it without expanding. 6 times 5 is 30. Now we have to remember that this 4 is 40. So 6 times 40, just like here, except we're going to do it mentally. 6 times 40, 240, okay? And this is 200, just like over here, 200, okay? And we got to remember that, though. 6 times 200 is 1,200, and 0, 7, 4, 1,407. Same answer, of course, but here we're using the method where mentally we think about times 10, times the 1, 6 times 1's, 30. 6 times 40, we have 240. We have to have a 10 in there. And hundreds, we got to have 2 of them, like we did over here. Okay, so there's a couple ways of doing the multiplication. The last way would be, again, that shortcut method, 245 multiplied by 6. 6 times 5 is 30. We write down the second 30, and we carry the 3 tens. And that needs to be added on, just like we did over here. We're going to add 30 on. Okay, 6 times 4 is 24, and we add 3 on to 24, 25, 26, 27, and we carry the hundreds, because it's 2710, so we carry the 2 over to there. We're going to add 2 more on after we multiply, just like we did here. We added these on. So 6 times 2 is 12, add 2, 13, 14. So there's the shortcut method if you want to try to use that. But any of these work for the multiplications. Any model you want to use, again, works. There is the distributive property method too, which says 6 times 245 is 6 times expanded 200, expanded notation, hundreds, number of tens, number of ones. And so if we distribute the 6 out, 6 times 200, 6 times 40, 6 times 5, and that's why it's called distributive. So 6 times 200 plus 6 times 40 plus 6 times 5. Okay, so that's 1200, 6 times 200, plus 6 times 40, 4 times 6 is 24, 6 times 5, 30. And you add these up, you get the 1,470. So there's another way, the distributive property. Okay, so I'm going to give you a problem, and I would like you to take and work this problem. Okay, 314 multiplied by 3. I would like you to put me on pause, work that problem. When you're finished, come back. Okay, here we are. I hope you work this. I'm going to use this method of partial sums. I'm going to multiply 3 times 4 and get 12. Okay? Now, I got to think this is 10. This one here is 10. It's 110. So 3 times 10 is 30. That's the next one. It's not 3, it's 30 because it's in the tens place. The 3 is in the 100. 3 times 3 is 900. Then we add them up. 2, 4, 9. When you add 1 and 3 is 4, and 9 left over. So the answer is 942. I hope you got that. But I'm using the partial sums where I'm thinking about these. Now, if you wanted to do expanded, you do the 300 plus 10 plus 4 multiplied by 3. And you'd get the same thing, wouldn't you? 12, 10, that'd be 30. 3 times 300, 900. Add them up. 2, 4, 942. So this is what I did, though. I used it mentally, without writing it out and expanded. But either way, nice ways to do it. You could draw the area or do the distributive property, whatever works for you. Well, I think that teachers can answer any questions you might have about this lesson and probably have some practice. It'd be good to practice. You don't make the Olympics unless you practice. So I hope you understood this lesson today. Enjoy your mathematics.